Hi, welcome to this Adapt Builder tutorial. In today's tutorial, we're going to discuss how we can model a braced frame in Adapt Builder in multi-story mode. And we're going to end up with something that looks like this. This is an analyzed frame. If I go back to the original base model, we can see, let's go over here to the visibility panel under the rendering. We can see we've taken two shear walls which were located on this inner core, and we've converted them into a idealized truss model. So um, we have tension and compression members, struts and ties that might be idealized, and we're using concrete components to model these. So we're going to show how we can go about modeling this configuration, and we'll end up with the same result here. We're going to start by looking at the main model. And in this main model, we have a 9-story structure. We have some shear walls. We'll go ahead and I'll come back to that rendering. And we can see we have this internal core that we're going to convert again into two idealized frames, or excuse me, two idealized braced frames or trusses, vertical trusses. So we're going to go ahead and start with that process. The first thing we're going to do is just turn off some of the component visibility, and we'll go immediately to wall design. We can select walls only. So I only want to really see what I'm working with here. Once I take it and condense it down to that, I could actually select these walls. Under visibility, I can hide that selection. So we're left just with the main walls that we're going to be modifying. We're going to now create vertical chords for the trusses or for the frames, and we'll go over here to model column. We're going to use a column component to do this, and I'm going to go immediately to properties, and we're just going to use a 12 by 12 square column. So we'll just use a 12-inch column. The material here is set to material 1. This is the default material. It's 5,000 psi. You could go into the criteria and set up additional materials with properties for that material. So we'll just take this column. I'll model it in 3 locations. Now the thing to note here, I'm actually working in multi-story mode. The active plane is set to level 2, so anything that I model will be modeled from level 2 down. Okay, even if I came up here and I tried to model at this level, it would still be placed vertically in that plane at level 2 down. So that's important to note. We're in multi-story mode and we're modeling with active plane set to 2. Now what I'll do is I'm going to set the releases for this vertical stack of columns and the offsets, and we're going to make sure we don't have any translational or rotational releases for the chords, and for the offsets we'll make sure those are set to 0. We don't want to have an offset over the slab depth for this type of an approach in modeling. So we'll now take these components. I'll just select the 3 by pressing Control, and I'm going to go ahead and go to modify. I'm vertically going to copy these up 8 times. Okay, so we've copied that up 8 times. We can actually get rid of the walls now. We don't really need the walls. So I'll just select those and delete them. We could actually just say select by type, wall, and it's only going to select what's visible in view. So we'll delete that. I'm now going to go back to model, and I'm going to create the vertical elements in this frame. So we'll go ahead and use a beam component to do that. And again, this is going to be a 12 by 12 member. In this case, we're going to select and choose to release rotation. And that's going to release the bending, I guess, about the local S axis. We may also want to release bending in the about the other axis. So in order to do that, we would have to impose some stiffness modifiers for the component. Okay, so we'll go ahead and notice I tried to model at the top. It modeled it down on the bottom. That's fine. We can go back and just copy that vertically. I'll come back to modify, vertical copy. I'm going to copy this up again 8 times. Okay, And the way that this truss is going to look, let's go ahead and look at, we're going to have some diagonal elements that look something like this. Okay, and we'll do the same thing on this side, something that looks like that. So we're going to use columns, and the column elements can be offset. So we'll start again at level 2, and I'm just going to take a column, go back to model. I'm going to make this a 10 by 10. I'm going to change the size for us, just for, make that 0. And you'll notice that I have to place it at one of the existing columns. When I do that, the program will ask, you have duplicate columns. Do you want to continue, or do you want to exit out of this or cancel out of it? We're going to select OK to continue. And I'll just take that column now. And if we double click on that element, I can go to location and I can offset this in any coordinate, X, Y, or Z, positive or negative. In this case, we're going to take the bottom and we're going to shift it in the positive X direction by 120 inches. This is a 10-foot frame. This is 5 feet. So we'll say 120 offset. And now I'm actually going to copy that using modify copy. I'm going to copy this to level 4. I'll come back and use the same thing. I'll copy to level 6. And then one more time, we're going to copy this to level 8. Okay, and I'm now going to take this and I'm going to copy it now to the bay above. So we'll copy this actually to level 3. But I'm going to now modify the offset. So now in this case, we're going to reset this to 0. And at the top, we're going to offset that by 120, something like that. And then we'll go ahead and copy that to levels 5, 7, and roof. So we'll say level 5, level 7, and then to the roof level. Okay, we'll save that. And if you look at the rendering of this, this helps us visualize what we've modeled actually a little bit better than the skeleton or the hidden or the wireframe mode rather. So we have something that looks like this, and we'll copy that over to this other frame in this case. Now we could take these and just rotate them about this vertical axis. In this case, we're going to remodel them because if we rotate them, we would still have to stretch the nodes back. So I recommend you just model similar to what we had done here. We'll come back and we'll model a column. Notice this already contains some offsets. So we'll model that there. And I'll take this, and you can see this is actually offset in the X direction. It needs to be offset in this case in the negative Y direction. So the top will be negative 60 here. And again, we'll do the same thing. We'll copy that vertically to levels 4. You can only copy vertically to one level at a time in this case. Or we could copy to all levels above and then go back and manipulate the offsets. That's another way to approach this. Okay, we'll copy it up to level 3, and then I'll change the offsets here. So we'll come back to location. This is going to be 0. This will be negative 60. And then we'll change that and copy to the remaining levels here. So level 7 and then level 5. Or excuse me, roof level. And then finally, we'll save that. We have something that looks like, coming back to the rendering, something that looks like that. Okay, and that's part of a more globalized model where we have slabs and other shear walls and so on. So if we double click on these components, we should have releases set to them. If we don't, if there's any issue with releases, we're going to go ahead and just select the components that require the releases. So here it's a little bit hard to select those unless I change the view. We're just going to select individually like so. And globally, I'll change the releases by going to modify For beams, we're going to go ahead and change release here. Notice you have to do this individually, so we'll do beams first and we'll come back. Everything is still selected. We'll do columns second and we'll release here for columns. Make sure that's checked. Okay. We could also change, maybe we want to change the color of these frames and group them. So we may have a need to isolate the group just so we can see this. So this whole stack actually might become its own group. I'll go over here to group library and I'll just create a new group and I'll say I'll call this braced core. Okay, and then we'll change, if we modify those components again, we can change the color of the components just so they're isolated, let's say, from the remaining structure in terms of their visibility. Easy to identify. Something like that. And if we come back and turn on the entire model, I'll go over here to default display. You can see under the rendering we have that frame, those couple frames now developed. If we wanted to isolate it, we could go back to group library, turn basically everything off, leave that on. Okay, and actually I think we need to go back and make sure that's actually set to the proper layer. So let me go ahead and turn these. I'm still working in multi-level mode. I've just selected a stack of openings. If I come back to multi-story, you should see the openings selected on each level. Okay, so I'll turn that off just for a moment. I'll go back to visibility, hide selection. Now I'll select this and I'll assign that to this particular group. So we'll go to modify selection and I'm going to assign it to the braced core group. Come back, and now if we go back to the group library, we should be able to highlight that. Okay, so that's working for us, the visibility. And we can see, coming back to the beams, if we look at the releases on the beams, this release is only about the local S axis. So if on a beam element, if we look at the axes, this will be S. So we're releasing the bending essentially about the main flexural direction. If we wanted to release torsional, the torsion, bending about an R axis, we can do that either through use of a stiffness modifier, where we can apply, if we double click on that beam again, we could apply a modifier set to bending about 1,1. So this M11, we would edit a usage, add a usage, apply a modifier, and then run the model under that modifier. Another option would be to go under the criteria settings under analysis and design options, and here we can disregard the torsional stiffness of beams or produce some lower percentage other than 100. So that's another way to handle that. We're just going to leave it alone for now. For this model, we're going to go ahead and create 2 additional combinations just to run this and look at some of the behaviors. So we'll go to the loading input. I'm going to set this to no code check. We're going to say that we have 1 times wind in the X direction, that's the wind P0, 1 times wind in the Y, wind P90. And this is in the positive directions. We could also produce negative directions using negative factors on the combos, or by imposing a new set of loads in the negative direction. We have 0 degree and 90 degree, which correlate with the global axes. We could also use 180 and 270, which is in the negative X and negative Y directions. Let's go ahead and mesh this. Okay, and we're going to execute this for the set of combinations. We'll select yes to save that solution, and I'm going to go back and just default display this. I'll turn off under the result browser. If we go to analysis, I'll come back and just clean the result view. Going to the legacy viewer here, if we wanted to look, for example, at the deformed shape in the X direction, we would select X under deformation, and we'll look at just the wind in the X. We can see This will actually show us the contours. This is really the slab contours, and you can see the displacements at the slab. And you also see here the frame diagrams, the frame displacements for that combination. If I turn on the numerical display, that will show me the frame values for displacement. We could also just look at a deformed view of the entire frame structure. So this kind of helps us see what action and behavior is going on here with application of the X load, and then we'll do the Y load. This is wind in the positive Y direction, and let's go and look at this would be Y translation. Okay, and one thing we want to maybe identify are what are the forces in the frames. So we're going to go back to our visibility under the group library. I'll turn off everything except for the braced core. And in the braced core, you can see the program is showing the frame elements. I want to turn those off. I'll go over to analysis under this visibility panel. I can turn off the elements, and also I want to turn off all of the nodes. Okay, now we can take a look at axial forces in the elements. So under analysis, we have columns and beams. I'll collapse that first just to show where this is located. We'll go to the columns first. Actions. This allows us to see the axial forces for combinations. So in this case, we're looking at the wind in the X direction. That's called NOC1, and you can see the axial force build up in all of the truss elements here. This is the vertical elements and the braces. If I wanted to turn on the struts here, I guess in the X direction, XZ plane, and here we have the YZ plane, then we would do the same. We would go to actions for beams. They're modeled as beams, and turn on those axial forces also. And you can see the distribution of the forces in the different elements for this frame under those loads. These components can be designed if we had design cuts, for example, for the beam elements. We could technically design them for the axial forces in the program. Primarily, the design strip method in the software is primarily driven by flexure, but there is some capability of designing it axially. For the columns, we could design these columns, these vertical elements, and also use a similar approach to design the members, diagonal members, as columns also. So if you have any more questions related to this modeling method, please let us know. You can contact us at support@adaptsoft.com. Thank you.